Well, this is the very first problem on the concept of stoichiometry. Now, there's few things that are going to be constant irrespective of what the problem is. First, there will be a question, and usually the question comes with a balanced equation. Now, in some cases, I would actually give you the equation. Some cases, I would give you the name, and it is your job to figure out the formulae on either side and then balance the equation. All right. Now, in this case, I've made your life simple. Now, we've spent a considerable, why do I do that? Why can't I just give you the formula all the time? Because I have spent a considerable amount of time teaching you how to write formulas. So it's important. You don't always have to be given the formula. Sometimes you can be just given the name and you can write the formula, right? I think I have shown you how that works as well in the past. So you need to be familiar with that. In this case, here's the question. It says when N2O5 is heated, it decomposes. That's the chemical reaction. And here is the first question. Here's the second question. It's asking you, now, one cool thing about stoichiometry, like I said, some things stays the same. That is, you will always be comparing multiple reactants to one single product. In this case, well, you only have one reactant. So you're comparing this reactant to this product and this reactant to this product. This is one of those kind, okay? You will see multiple different ways of doing this, okay? But before you actually start working out the problem, you need to know if your equation is balanced, and 99.9% of the time, I would never give you an equation that's balanced. Now, the purpose of this particular video is to drive the idea of mole ratio. Remember that one of the terms you would learn, I said there's three things: percent yield, mole ratio, and then limiting versus excess. Mole ratio, that is like a heart of a stoichiometric problem. How do we even get to mole ratio? Means you need to know how to balance your equation first. So we got two nitrogens, one, so I'm just going to put a 2 here. And in the process, I've changed my oxygen count. 4 plus 2, 6. Here I have 5. So what if I put 2 more here? Okay. Well, that will change my nitrogen to 4, right? And it works out now. I have 4 nitrogens, 10 oxygens, right? Does that make sense? Okay, so this is 1. All right, so it's asking how many moles of NO2 can be produced from 4.3 moles of N2O5. As with any other mathematical problem in chemistry, you always start with the given information, which is this 4.3 moles. Again, write your actual units. Don't just write 4.3. That has absolutely zero meaning. You always put your given information on the far top left-hand side and put a 1. And then here is the idea of mole ratio is, well, your N2O5, we're comparing two compounds, NO2 and N2O5, right? What is the N2O5 is on top, which is not something we want when we're finished. So the mole ratio is 2 N2O5, right? That's the ratio of 2 N2O5 to 4 NO2. You cannot put the 2 NO2 N2O5 on the top because we're trying to cancel this out. We're trying to get the answer in how many moles of NO2 is formed, and that's it. So we cancel out the N2O5. We want the moles of NO2. I'm writing 4 NO2, which is same as writing 4 moles of NO2. I wrote it that way because it's easy for the brain to remember it this way than this way. But this is exactly the same thing, and 2 moles of N2O5. That's the same thing as writing 4 NO2 and 2 N2O5. Okay? Because there's moles, we got what we want, which is moles of NO2 is what we want. This right here, folks, is called a mole ratio. You adjust based on what you need to cancel and what you need to end up with. So I'm just going to do the math here. Isn't that simple? 4.3 times 4 divided by 2 is 8.6 moles. And that's it. You always want to be ending up with what the question asks you to calculate. So you have to determine whether the 2 goes on the bottom or the 4 goes on the bottom. Well, in this case, the 2 has to go down because that is associated with N2O5, which needs to be get rid of. So following along the same route, you're starting with 4.3 moles of N2O5. The given information always goes on the far left top column and 1 goes on the bottom because there's nothing to put. And we want moles of O2, right? What is the ratio of O2 to N2O5? It's 1 to 2. The 2 goes on the bottom because that's what is associated with N2O5. The 1 goes on the top because that's associated with O2. Now, I could keep writing this way, but I personally have found that the less terms are on the equation, it's easy for the mind to register that information. I'm not spoon feeding again, let me repeat, it's just making the equation work to our favor. And that's exactly what I have done. And when I do the math, I get 2.15 moles of O2. Again, this is the mole ratio. Why do we need the mole ratio? For everything in life, there's a rationale on why we do. Because we have to get rid of this N2O5, and this is in moles. And the only way we can get rid of this moles of N2O5 and get moles of NO2 or moles of O2 for the second part, we have to use the idea of mole ratio, and that's all. All right. Now, this is not actually a full problem. We have not completed the problem. For this case, yeah, we're done with the problem. But in a real world sense, we'll be continuing further, which is what is our next real problem. The purpose of this particular problem is I chopped it halfway just to showcase the idea of mole ratio. In a real problem, well, you can expect the problem to stop here on your exam, or you can expect it to go further, which we have not learned. But I purposefully chopped it off halfway just to showcase the idea of mole ratio and how to set up the problem and explain to you the rationale behind why we do the way we do. All right, this is the idea of mole ratio, right? It all begins with balancing the chemical equation and setting up the problem the right way. Now, you would always have problem if you don't write like the way I'm doing, like moles of N2O5. You just write 4.3 over 1. If you're one of those people that is struggling, then you're going to only add more fuel to the fire, means you're only going to increase your pain of not understanding the material. So this is how you do mole ratio. So stay tuned for the actual full version of the problem.